Now we are moving to Gauss theorem, a very important theorem and very easy but conceptual problem they are discussing about this Gauss theorem. Theorem is very simple. If you enclosed a Q charge in a surface, then electric flux related to surface should be Q upon epsilon naught. What are electric flux? Remember, we cannot see electric field by our naked eyes. So how to make electric field on a paper? We are making electric field by electric lines of forces. What are electric lines of forces? Path taken by unit positive charge in that electric field. Path taken by unit positive charge in electric fields are known as electric lines of forces. You know that if you put a unit positive charge, it will experience a force in the direction of electric field. So arrow of electric lines of force is indicating the direction of electric field. If these lines are parallel and equidistant, it means your electric field is uniform. If they are parallel but not equidistant, at some places they are very close to each other. At some places they are at some distance from each other. So what you will say, in a direction electric field in terms of direction is uniform, but in terms of magnitude it is not uniform. Where you are drawing electric lines of force nearby means closer to each other, at that point electric field is known as stronger. If you are drawing a lines at a distance from each other, it means you want to indicate that at this point electric field is weaker. It means it is uniform in terms of direction. At each and every point direction is same, but magnitude is not same. If you are drawing a lines like this curves which are equidistant, what you want to say, that at this place electric field is uniform in terms of strength because lines are equidistant, but not in terms of direction. Getting my point? So this is the way to represent electric field on a paper. So if electric field is there, it means electric lines of force are passing from that place. If you put one coil or one surface in that place, the number of lines of force which will cross or hit the surface perpendicularly are known as electric flux. So what they are saying, if you enclose a Q charge in a closed surface, flux related to that surface should be Q upon epsilon naught. It is the statement of electric flux should be equal to Q upon epsilon naught. It is a statement of Gauss theorem. You know that with the help of this Gauss theorem, we got so many results. If I have an infinite long wire and is this wire a positive charge is uniformly distributed, it means in each unit length charge is same. It is known as linear charge density. charge related to unit length is known as linear charge density, and charge related to unit area is known as areal charge density, and charge related to unit volume is known as volumetric charge density. Generally, linear charge density is denoted by lambda, areal charge density or surface charge density by sigma, and volumetric charge density by rho. Suppose I have an infinite long uniform linear charge distribution. So, at nearby point means at r distance, what should be the electric field? In your school preparation, you have proved this with the help of Gauss theorem. What you got there? You got 1 upon 4 pi epsilon naught lambda by 2r. What should be the direction? If it is positive charge, the direction should be this. Negative charge, it should be this. Areal charge density and electric field near a sheet of infinite uniform charge distribution. Suppose charge density for this infinitely charged sheet means sheet is of infinite dimension, but charge density is same everywhere. Suppose it is sigma. So, first point you should note, you should remember, and you proved this in your school exams, that near a sheet electric field does not depends upon the distance. Near a electric sheet, near a charged electric sheet, electric field does not depend upon the distance, and it is equal to, at any point, it is equal to sigma upon 2 epsilon naught. It is sigma upon 2 epsilon naught. Sigma is surface charge density. It means, what do you mean by sigma? Charge per unit area. Lambda, charge per unit length. Rho, charge per unit volume. It is very important result. Many types of problems they are framing on this concept. See, I am putting 2 plates. One is positively charged of charge density sigma 1. One is negatively charged, charge density sigma 2. Tell me, at this point, what should be the total electric field? We know that if we put +1 charge, first check the direction of electric field. This sheet will repel it, means electric field should be in this direction, but this sheet will attract, so it should be in this direction. Since it is independent of distance, so it should be given which one is greater. Suppose this is greater than this. So, what is net electric field? Since electric field is a vector quantity and both are acting in opposite direction, so net electric field should be difference of them. Which one is greater? Since sigma is in numerator, if sigma 1 is greater than sigma 2, electric field of 1 should be greater than of 2. So, we will write plus first sigma upon 2 epsilon naught sigma 1 minus sigma 2 upon 2 epsilon naught. So, in this way we can solve this. Number 2, if you have only one positive charge, electric lines of force will start from this and end at infinity. They will end at infinity. But if you have negative charge, they will come from infinity and end at this charge. If they are starting from a charge or ending at a charge, they will start or end at 90 degree only. So this was all about Gauss theorem. One more thing is this: if you have one conducting shell, since inside the electric shell there is no charge, so inside the electric shell electric field is 0. But for outside any point it will behave like this, that whole charge is at its center. Means if you give q charge to a sphere, what will happen? At r distance from its center, electric field will be 1 upon 4 pi epsilon naught q by r square. Either it is on surface or at distance from surface. But if you have non-conducting sphere of charge, now everywhere there is charge and charge density is same. So inside the non-conducting spherical distribution of charge, electric field will be directly proportional to R. But what will happen outside? Outside this, it will be inversely proportional to R square. So if you will put a graph, so for inside, what we get for inside? Inside we will get E proportional to R, and outside it will follow inverse square law. So if you will put a graph, you will get like this. It is very important for non-conducting spherical distribution of charge. So what we will do now? Now we will go for one most important point, which is condenser, capacitor and capacity. That is again for competitive purpose a very important concept. So now we are going to discuss capacitor and capacity. For examination purpose, an important point to discuss. What is capacity? I told you in hydrodynamics, if you are putting some liquid into a container, what will happen? Liquid level will rise. If you remove the liquid from container, liquid level will down. And container has a capacity, after that you cannot put liquid in that. Same thing is happening here in electricity. Every conductor has one capacity to store the charge. After that you cannot put charge on that conductor. Insulation of air will break and it will leak, like your bucket. So it means if you are giving charge to a conductor, the physical quantity which is increasing is known as potential. So potential is playing the role of liquid level and charge is playing the role of liquid. If you remove this sign, you will get one constant which is known as capacity of that conductor. If Q is in coulomb, V is in volt, you will get C in farad. But farad is a very big unit. So we are using Microfarad, micro you know 10 to the power minus 6, or picofarad. Pico you know that 10 to the power minus 12. So we are using microfarad and picofarad. Dimensions you can calculate from this. Its SI unit is farad, and what I told you, for CGS unit put stat in front of it. So what you will get? CGS unit. So in 1 farad there are 9 into 10 to the power 11 stat farad. Now if you have one conductor of radius r, what should be its capacity? We know that if we supply Q charge to this conductor, what will happen? Its potential will increase. And what is the potential of this conductor? For surface and outside any point, this conductor will behave that all of its charge is at its center. So potential of surface should be 1 upon 4 pi epsilon naught Q by R. Regarding potential, note down this: potential is a scalar quantity. If you want to add two potentials, simply you can add. For negative charge, potential is negative. For positive charge, potential is positive. Since inside the conductor electric field is 0, so if you are taking a +1 charge from infinity to surface, you have to do work, but inside you have to do no work. So inside the conductor, everywhere potential is same, and it is same as it is on the surface, because up to surface you have to do work, after that no work. So what potential you got at surface, inside at every point that potential is there, and work done you know from 10th class is charge into potential difference. If you are moving a charge in one electric field, what work you have to do? Work done means charge into potential difference. And what is the relation of potential difference with electric field? It is minus dV by dr. If at dr distance potential difference is dV, then electric field between that 2 points should be minus dV by dr. But if there is a function which is in terms of x, y and z, you can write it like this: delta upon partial differentiation with respect to x into I cap electric field plus j cap partial differentiation with respect to y plus k cap partial differentiation with respect to z. So electric field you can calculate by these two formula, and this is the relation of electric field and potential. It is potential. So we will denote it by V, and work is charge into potential difference. So what potential we got? 1 upon 4 pi epsilon naught Q by R. But C is Q by V. C is Q by V. So capacity of this spherical conductor should be Q by Q upon, it will go in numerator. So what we are getting? C is equals to 4 pi epsilon naught R. We are getting C is equals to 4 pi epsilon naught R. So it means capacity of a conductor is directly proportional to its radius. If you are going to charge one conductor, suppose you want to give 10 coulomb charge to this conductor. I connected this with battery. What will happen? First 1 unit of charge will reach the conductor. Now second unit is approaching the conductor, but first unit will repel that second unit. So battery has to do work in charging or to put second unit on this surface. Now third unit is coming. These two units will oppose that third unit. It means you have to do work. That work will store in the form of potential energy in conductor. And you know that what is the expression for that potential energy? Half CV square. But Q is equals to Vc. If you want to remove C, you can write Q upon V. So you can write it half Q into V. But if you want to remove V, you can write Q by C. So you will get half Q square by C. So it is the form of this electrical energy which will store in the form of potential energy in conductor. If you have two charged conductors and you are connecting them by a wire, what will happen? Suppose this conductor has charge Q1, potential V1 and its capacity was C1, and it has charge Q2, its potential was V2, its capacity was C2. See, if you connect two containers on which there was different amount of liquid, different level of liquid, what will happen? After some time, liquid level will be same. Same thing will happen here. After some time, there will be redistribution of charges. Suppose now Q1 charges on this, Q2 charges on this. Now what will happen? Potential will be same. What is the value of this common potential? We can calculate. What is Q1? Capacity is constant. So after connecting or before connecting, capacity should be same. So Q1 is equals to now Vc1. Q2 is equals to now Vc2. So what is Q1 by Q2? We got Q1 by Q2 is equals to C1 by C2. Next thing, now you connect two conductors. So total capacity will become C1 plus C2. Total charge is same because there is only redistribution of charges. What initially it was there, now it is again there. Means by law of conservation of charges, Q1 plus Q2 should be equal to Q1 plus Q2. So now potential should be Q1 plus Q2 divided by C1 plus C2. So we can write C1 V1 plus C2 V2 upon C1 plus C2. It is the expression for common potential, and this is important result, that charge will redistribute in the ratio of capacity. In the ratio of capacity. But we know that if conductors are spherical, capacity is proportional to radius. So we can write charge will redistribute in the form of, in the ratio of radius. So they can ask some problem based on this concept, and orally you can solve. How? I will tell you. Suppose I have two conductors. How we can solve orally? I am giving you one problem. See, I have two spherical conductors. One of radius, suppose 2 centimeter, and radius of second conductor is 5 centimeter or 3 centimeter. What will happen if charge on this conductor was 17 microcoulomb and charge on this conductor was 8 microcoulomb? If I connect these conductor A and B they will ask what amount of charge will flow through this connecting wire and in which direction. See, I told you that charge will redistribute in the ratio of radius. It means if I make 5 parts of total charge, 2 should be on A, 3 should be on B. So add total charge. What is it? 25. Make 5 parts of that. 25 by 5 means 5. Put 2 units on A, 3 on B. So 5 into 10 to 10. So after connection, on this it should be 10 microcoulomb and on this it should be 15 microcoulomb. But initially there was 17. Now we want 10. So what will happen? 7 microcoulomb will flow towards B. So without pen and paper, we are able to solve this type of problem. If you know the concept, you can solve it. Next thing, what is capacitor? Capacitor means an arrangement by which without touching the conductor, you are able to increase the capacity of conductor. How? See, I have one plate. I charge this plate. Its capacity is over. Now I cannot charge it. What to do now? Put one plate, conducting plate near it. What you will get? By induction, opposite charge on nearby face and same charge on opposite side. This charge, which is plus in nature, will try to increase the effect of this plus charge, but minus charge will try to decrease the effect of this charge. So this minus charge bound some lines of force of this, so that place is now empty. You can put more charge on that place. Further, if you want to increase the capacity, connect this plate with earth. What will happen? The supporting factor of this charge now will move towards earth. And you know that earth's capacity we are considering like infinity too much, but it is not infinity. It is nearly 711 microfarad. So charge will go in earth. Now only that factor is there which want to reduce the effect of this charge. To take place of that charge, you can send some more charge. So in this way we increase the capacity. If you want to decrease the capacity, again put some dielectric in between the plates. I told you in previous slides, it will reduce the electric field. So in this way it will reduce the potential. C is equals to Q upon V. If you are reducing V, means further you are increasing C. So in this arrangement, we are able to increase the capacity of conductor without touching its shape and size. This is known as parallel plate condenser, and its capacity you can calculate by epsilon naught A upon D. If dielectric constant is there, then capacity will become K epsilon naught A upon D. If we have more than one capacitor, you have done calculations in your derivations in your 12th board exams. Okay, if you are connecting capacitors like this, it is known as series combination. Second plate of first capacitor is connected with first plate of second capacitor. What will happen? All capacitors will get same charge. Charge will be same, but potential difference will different. Total potential difference, if there are 3 capacitors, will divide into 3 parts. Means sum of these potential difference, total potential difference. But what is total charge? Individual capacitor gets same charge. You know the phenomena. If capacities are C1, C2 and C3, you can calculate this by this formula. 1 upon C is equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Getting my point? But if you are connecting like this, this is known as parallel combination. Since one plate of each capacitor is connected at one point, second at one point, so potential difference, what is total? It will be individual. So potential is same what is total, but charge will distribute. If on this Q1, on this Q2, on this Q3, it means total charge will divide in 3 parts according to capacities. If capacities are C1, C2 and C3, you can calculate total capacity by the formula C1 plus C2 plus C3. In the process of charging a capacitor, what is happening? Energy is stored between the plates in this electric field, and you can calculate energy per unit volume. That is important for competitive purpose. Energy, it is known as energy density. If you know the electric field, you can write this 1 upon 2 epsilon naught E square. It is energy density. Which type of problems they are asking from this? Some conceptual problems are there, and what to do in that case? Remember one thing. If you are disconnecting the battery, means they will ask this type of questions. Okay, I have one condenser. Condenser was charging through a battery. I was charging the condenser with the help of a battery. Now I disconnect the battery. After that, I increase the distance between the plates. What will happen to potential difference between plates? What will happen to V? Or what will happen to energy stored between the plates? C. What we say? Ki we remove the battery. It means if you remove the bucket from the tap, it means now water content is constant. So in same way, if you remove the battery, it means you make charge constant, but you are increasing the distance between the plates. You know the formula for capacity, epsilon naught A upon D. Increasing the D means decreasing the C. Q is constant and C is decreasing. So write energy in terms of these two only. What is energy? I told you in terms of Q and C, Q square by 2C. Q is constant, C is decreasing, it means E should increase. So value of E will increase. Or they can ask, in the process of charging a capacitor, I am not removing the battery, but I am putting some another medium between the plates of condenser. What will happen to battery? Will it increase or decrease? If we are not disconnecting battery, potential difference was due to battery. It means you are making V constant now. V is constant. Now, by putting dielectric, you are increasing the capacity. So, if you want to discuss about energy, now take the help of these two. What is energy in these two terms? It was half CV square. V is constant because still battery is there. So potential difference is supplied by battery and that is constant, but you are increasing the C. It means again we are increasing the E. Getting my point? So in this type of problem they can ask. Second time they can do this. I have one capacitor, parallel plate capacitor. What I did now, its capacity was C. I put two mediums. In first half, I put one medium of dielectric constant K1. In second half, I put the medium of dielectric constant K2. What is the new capacity of this condenser now? What is the new capacity of this capacitor? Suppose area of plate initially was A and distance between the plates was D. Now your system will behave like two capacitors like this. Second plate of first capacitor is working as first plate of second capacitor, means we can connect them. So I think you get the point. These are two condensers which are connected in series. Area of plate is same for both and what it was in previous case, only distance between plates reduced to half. So if capacity of this is C1, capacity of this is C2, what should be C1 now? K1 epsilon naught A by D by 2. And what is C2? Similarly, 2K2 epsilon naught A by D. But in series, 1 upon C, now total capacity should be 1 upon C1 plus 1 upon C2. Means D upon 2K1 epsilon naught A plus D upon 2K2 epsilon naught A. So 1 upon C should be equal to, take D upon epsilon naught A common, 2, we can take this 2 also common, 1 upon K1 plus 1 upon K2. So what we are getting, 1 upon C is equals to D upon 2 epsilon naught A K1 plus K2 by K1 K2. So C should be now epsilon naught A by T into 2K1 K2 by K1 plus K2. Epsilon naught A by D is old capacity, it is new capacity. So we can write this 2K1 K2 upon K1 plus K2 into C. So in this way they can give you problems and you are able to solve. So now we will go for our assignment of 45 questions based on these principles. Thank you.